Okay, so this week we're looking at reading and writing files. So I've made some example files for us to read here. So let's have a look at this one, xy.txt. So this is a file that just has two columns of numbers in. We're going to read them in as x, this column, and y, this column. And there's a few different ways you can do this in MATLAB. So we'll look at three different methods for reading files in, and then we'll talk a little bit as we go along about maybe why they're better, or why one method is more useful than another. And probably you should always use the method that's simplest. So first of all, let's create ourselves a new script. Let's call it read file. Read file. Alright, and let's put the usual header information in. Script that reads from a file. Oops. And first of all, we'll use fscanf, the fscanf function, to read this file in. Alright, first thing we need to do is open the file. So, open the file. For this we use fopen, and fopen returns a handle to the file. So all you need to do is give it the file name here, and if you want to open it for reading, that's all you need to do. If that file doesn't exist, or if it has a problem opening the file, then file ID, the file handle, will now be -1. So we can test whether file ID is equal to -1. And if it is, that means there was an error. So we can stop our script with an error message, file could not be opened, for example. End that if block. So we'll only get here if file is open for reading. Alright, so let's just test what happens if the file is not there. So I'll change, the quickest way for me to show you that is to change the file name to something that's not in my current folder. So now if I run this script, it fails, file could not be opened, okay? But if I put the file name back to what I know is there, and run it now, it should finish. But of course I haven't read anything yet. So let's do that with fscanf. So we look at what our data looks like. It looks like two columns of numbers separated by white space. And in MATLAB we can read that in really easily using fscanf. So the little helper window there is showing you that it wants the file ID first. So that's the handle that was returned to you when you called fopen here, this bit. And then it wants the format. So it's two numbers separated by white space, and that will do it. We can also give it the array dimensions. So 2 tells it that there's two things across, 1, 2 columns, and inf means that it will carry on trying to read until it gets to the end of the file. So however many rows it is, it will carry on. So that's the bit where it reads in the data, and then we need to remember to close the file. So after we've read in the data, we close the file using fclose. So put a comment here, read the data using fscanf. Alright, so if I run this now, it should read the data into this variable called data, and because that now exists in the workspace, I can see what it looks like. So it looks like an array with 2 columns and as many rows as there are rows in the data file. If I want to split it up into x and y variables, then I would be looking at the first column for the x values. So when you just put the colon by itself, that means all elements. So that's at data bracket 1 comma colon means all the elements in the first column of the matrix data, or the array data. Similarly, if you do 2 and everything, that gives you the y values. So in your script, after you've read the file and closed the file, you could split up data into X and Y arrays using very similar to what we just did on the command window. So the reason you might want to do this is just because it makes your program easier for you to follow, or easier for you to refer to those things. And then you might, for example, want to plot X against Y. So that now is easy. You just do X, Y, and then let's say I plot it with red dots. Alright, so that should now read in the file xy.txt and plot the data with red dots. Okay, that's what it looks like. Alright, now let's see what happens if we have a file that looks a little bit different, but it's got the same data. So let's try this one, xy.csv.txt. So normally I would just have this file called xy.csv, but I've added the .txt so that MATLAB will open it in the editor, so I can show you what it looks like without having to swap programs. Okay, so this is the same data as xy, but it's in a slightly different format. It's in a comma separated value format, so each line contains x and y separated by a comma. Okay, so you can actually read that in exactly the same way as with fscanf. So let's change the file name so that it finds the right file. Everything should work, and the only difference this time is that I know that the numbers are separated by a comma. So in my format specifier for fscanf, I just need to make it match what my data looks like. So my data looks like a number and a comma and another number. And everything else will be the same. So this should do exactly the same thing, and just to prove that it does, I'll plot the points with a green dot instead of a red dot. So now when we look back at the graph, it should now be the same but with green dots. Okay, so you can use fscanf to read different types of format of file, and it really is a matter of you like what choices you make when you're designing your script, which method you think is best, because I'll now show you another way of reading that same file with the comma using text scan. Okay, so this script is going to be different from the previous one, so I'm going to make it a new script. So I'm going to save this as, and I'm going to call this read file text scan. Alright, and I will change the header information to match, like we always should. So this is a script that reads from a file using text scan. It's going to read the same file, so all this is still good. It will fail if the file doesn't exist or if it has a problem opening it. So it only gets here if the file is open for reading. That's still good. I'm going to comment out these lines for now. I'm going to leave the close file line because I want to close after, and this is the bit that I'm going to change to show you how text scan works. So read the data using text scan. Okay, so text scan. It takes the file ID, the file handle, as the first argument. Then it takes a description of the data. So again, that will be good. But now you don't need this bit now. And if you look at xy.csv.txt, the delimiter for the fields is a comma, and text scan has a special option for that. You use delimiter in apostrophes, and then whatever you put next is the delimiter in the file. So it's a string and it's a comma. So this is saying read me a line, or read the file. I'm expecting two numbers, and I'm expecting them to be separated by a comma. Right, so this should work. This should read the file. Read file text scan this time. And now I should have a variable data. And now the difference with this is that this variable data is now a structure. So when you type data on the command window, it's telling you that this is a structure made up of two things. It's made up of two arrays of double precision numbers. Double means floating point number, but double precision. We'll cover that in more detail when we start talking about C++. But what it's saying is that you've got two arrays, and because they're in a structure, if you want to refer to the actual array, you have to use curly brackets. So if you do what you think you would do, that's the array that you're referring to. If you want to actually look at the numbers inside the array, then you have to use a curly bracket. So that means that this program, this script, will work to plot the points like the previous script did, but this won't work anymore. We need to change it to this. So the X points come from the first element of the structure, which was the array, so that's good, and the Y points come from the second part, the second thing in the structure, which we refer to like that. So this should now do the same thing as the previous program. So now we should have the same data but in red dots. Okay, so that's how you use text scan. Text scan has another interesting option, which, let's say you had a line at the top of your data file that described the different fields, so in this case X, Y. When you read that in, you want to ignore that line, and text scan has an option to do that. It's called header lines, and then you put the number of lines to skip. Okay, so this should do exactly the same thing. Let's change the points to green so we can check, and then the points should be green. But what it did now was it read this file that has a header line, but it skipped that and then started reading the data after that line.